I will start off by giving you an overview of the building automation and control markets, and then we are going to look at the different factors impacting the market. I want to try and switch the slides here. Well, you're trying to move on to the next slide, so I don't know if you can, doesn't seem to move. Yeah, so that was the introduction, that's the agenda for today, and if we move on to the next one. Okay, to set the scene here, we'll start by showing the value of the global BACS market. The products, which include controllers, field devices, software and hardware, is estimated around US $7 billion, and we measure this in manufacturer selling prices. The estimate is based on research we have conducted in 2017-18 for 8 countries, and also 16 countries were researched in 2015 and 16. Other countries are estimated to get a more complete picture of the global market. The large share is controllers, so in that we include DDCs, room controllers and field level controllers. They account for 43% of the market, which is equivalent of around $3 billion. We expect growth up to around 3% per year up to 2022. Field devices, which include sensors, valves, dampers and actuators, account for 41%. So that is close to US $3 billion as well. Growth is marginally higher than for controllers. Hardware include gateways, routers, display panels, screens, server stations, is worth around 9% of the total market, so just over 600 million. We expect sales of hardware to be almost flat, as software and controllers are becoming more sophisticated, and tablets and smartphones are replacing fixed screens. Software is the smallest part, around 7%, so around $500 million US, but it's also the area where we expect the most growth. We have estimated around 10% growth per year up to 2022. Next slide, please. If we look at the market by regions, we can see that Europe is one of the largest regions in our study, followed closely by America, which here are shown as US separately and Latin America. Then next one down is Asia Pac, accounting for around 25%. If we're looking at Europe alone, Germany is the largest market in Europe, accounting for around 27%. The next level down is France, Italy, UK, Sweden. The next one. We did an interesting comparison looking at average GDP per capita and the market for BACS, again per person, as the chart shows here. As you can see, as we would expect, the BACS market are largest in the more developed countries such as Germany, US, the Netherlands, UK and France. At the other end, we have the less developed countries and markets such as India, Mexico and Brazil. The next slides show you the top suppliers. So the top 2 here are Siemens and Honeywell, followed by Johnson Controls. The top 3 do complete solutions and are also leading for controllers, software and field devices. The next level down is Yamatech and Schneider Electric, around half the size of the top companies. And if we look at field devices, we need to include Belimo. Other important suppliers of controllers, hardware and software are Kilbach and Peter, Train, Salter and Carrier. We have in this chart also added security, which are surveillance cameras, access control and intruder, and lighting as well. But these markets have a lot of different suppliers. In the next slide, you can see the uptake of IP products and controllers continue to increase. In our recent study, over half of the field level controllers were IP enabled, and the yearly growth is going to be around 45%, so twice the growth rate for non-IP controllers. It is also worth mentioning here that we see an increasing use of open protocols such as BACS. The next slide gives you an idea about the uptake of cloud. Supervisory software is sold as part of the operational system. It's the brain behind the BACS. Some suppliers sell the software in modules with additional modules for energy efficiency, advanced maintenance, and so on, while other suppliers such as Lyngspring, Sky Foundry, Neutron specialize in energy efficiency software and sell them as separate packages. The use of cloud software is limited. 93% of the end users still prefer to use software installed on premises. Most of the software sold are cloud-based, but many end users are nervous about security and choose to install it on premises. The uptake of cloud-based software is estimated to be around 5%, but countries like France and the UK have a slightly higher uptake. Software as a service has emerged over the last few years. A few European suppliers that has promoted it is companies like Redin and Priva, who offer it via their partners, their system integrator partners. The next ones show you that the building automation and control market has for years been a stable market with modest growth. But under the surface is a lot of interesting developments which are happening, and we are going to look at them in the next section. So I will pass you over now to Henry.
Okay, thank you very much for that, Lorna. So I'm going to start off by talking about smart connected HVAC. And before I explain exactly what this is, if we go to the next slide, I'm going to talk a bit about the background and why there is a need for it and a demand for it emerging. Now what you can see here is an analysis we did of some of the major markets in Europe. Along the bottom axis you can see the average temperature in the largest city, and on the vertical axis you can see a percentage of GDP spent on a particular HVAC product. We choose split air conditioning as just as an example. Now what you can see here is, perhaps not surprisingly, up in the top right, the countries with the highest temperatures spend the most on this category of air conditioning, whereas if we go down to the lower left you can see, again, no particular surprise, countries like Sweden, the UK and the Netherlands, cooler, not spending as much. Well, so what? But the interesting point here is that because we can see this clear relationship, we also have strong grounds to think that the temperatures, average temperatures, are rising across the world, and this does suggest that as temperatures rise there is going to be more demand for cooling, and also that cooling is going to become more strategically important. And if we go to the next slide, you'll see a couple of examples of how this is so. So, for example, in hotel rooms, I think anyone who's spent a sleepless night in a hot hotel will know that it's going to be hard for hotels to let out their rooms if they're too hot or too cold for that matter. And also we've seen, particularly in the recent heat waves and high death rates for elderly people, that there are big issues for places that look after the ill or the elderly if they can't control the temperature adequately. So and if we go to the next slide, what we can see here is the typical schema for routine maintenance as we know it today. So you'll have a routine check of your systems, and then probably 6 months later, perhaps longer, the engineer comes back and checks them again. But of course what happens, faults don't occur when we want them to. What happens if one happens unpredictably? Well, firstly, it may well take some time before the fault's actually noticed. The symptoms may not be obvious, that if the system's being forced to work overtime, but eventually you notice it, you call out a technician, they come along, they diagnose it, which takes time. They may not then have the replacement parts, they need to go and get them, but eventually the fault is probably going to get fixed. In the meantime, though, of course, you potentially wasted a lot of energy, and just something as simple as a block filter could increase energy usage by up to 30%. And of course, if the temperature and the ventilation are not right, then you'll probably find that people in the building are going to be suffering and not being as productive as they should be. If we go to the next slide, we'll see here what is a potential solution to a lot of these problems, and this is where we come to actual smart connected HVAC. On the right you can see a typical chiller. In this case it has an IP connection where it's feeding regular data to the cloud. And within the cloud there are a number of operations going on. It's looking for faults, it's looking for data on the performance, so if it's underperforming in some way, and potentially, depending on the solution, it may well be able to use all this data to predict when a real fault is likely to occur. This information is being fed back to the support team over on the left, and at the appropriate time they can dispatch a technician with information about the problem and where appropriate with the correct parts. And this means that all being well, it should be possible in many cases to fix a problem before people working in the building even know about it. On the next slide, we talk about some of the more obvious benefits of smart HVAC. The first one that I've already alluded to is greater business continuity. If your HVAC systems are running pretty much without break, you're less likely to lose customers, you're less likely to find that you have perishable or vulnerable stock which goes off, you're less likely to have people who are falling ill. The second great benefit is energy saving. I've already mentioned the potential for saving energy if your HVAC equipment is working at full efficiency. You can also reduce the service and maintenance costs because you're not sending out staff or technicians unnecessarily, and they're also probably going to spend less time hanging around diagnosing a problem or waiting for the right parts to turn up. From the another big benefit from the point of view particularly about the manufacturers and suppliers is they get a lot of information about the user base and also about how their equipment is functioning, which should again feed into helping them to improve the design and the functionality in the future. Another benefit is that, as Lorna already mentioned, the growing importance of software and firmware, and this applies more and more to systems across the board. The software is key to its running. You need to be able to update it with patches, whether it's for security or for performance. And of course, if you've got an online connection, this is much simpler and easier to manage and control. And the end result we expect from all of this is that you can both the manufacturers and the supply and the maintenance teams can hope for happier customers and hold on to them for longer. If we now look at on the next slide at the main targets in Europe. Well, in Europe, in particular, it tends to be particular verticals where HVAC, cooling, refrigeration are important. Obvious examples are hotels, so that you can let out all your rooms. Anywhere which has, for example, chilled food or other stock which can go off if the temperature is not right. It's very important to have a means of fixing problems quickly. and also any organisations responsible for well-being, such as hospitals or residential care for the elderly, as we see here. Now, if we look at the next slide, you can see that there are, of course, different levels of this service available. They range on the left for the fairly simplistic version, where it's basically a remote connection telling you that something stopped working or some very obvious fault has occurred, and then going all the way through to systems which can do detailed collection of information, crunch this and come up with predictions about what's going to happen in future, and of course a lot of levels in between. And we've assessed the overall value of this market, and you can see that on the next slide. This is looking at the global HVAC business, and it based on Visual Research, and it includes everything: the hardware, the software, and all the services associated with it. And in fact, we, perhaps not surprisingly, our estimate is that the great majority of the value is a combination of services and extra sales. Again, as you might expect, the US market is by far the biggest. I mean, not only is it the biggest economy, but also, of course, in much of the US, air conditioning in particular is seen pretty much almost as a human right and essential for whole cities to function. But it's also growing in Europe, albeit from a lower base, and in other parts of the world where HVAC is critical. And the UK market, for example, is still fairly small, as it is in other European markets, but from the research we're doing at the moment, we can see that there is a lot of potential for growth and also interest. So, having seen this, that raises one obvious question, which we explore on the next slide, which is, if it's so great, well, why isn't everyone already doing it? Well, there are a number of issues that need to be addressed, or potential pitfalls. Firstly, if you're talking about serious analysis and accurate predictions, you need to be able to interpret the codes. This may be relatively easy for a manufacturer, but it can be harder for anyone who's coming in and offering a solution as a third party. You obviously need an internet connection. If you don't have already have your devices connected up to a local network and a router, then you may need something like a broadband connection, and of course, depending on how this is set up, you could be paying for quite a bit of data on a more or less continuous basis, and if you've got a lot of devices, this soon adds up. Now, there are things that you can do to limit the amount of information to what's really needed, but nevertheless, that's an issue. Another big issue, as you see on the top right, is that on the one hand, on the left, you want to avoid falling into a hole. The system's no good if it misses, if it fails to predict or identify when there really is a problem. But equally on the right, you don't want it going off all the time with false alarms. It's not much good if you're sending out an engineer twice a week just because some alarm has gone off when it's not really necessary. So hitting the target of the valid warnings is quite tricky. Another issue is who pays for the service. I think most people in the industry see this as a good idea, but will the customer be prepared to pay an add-on fee for this service? Well, it probably depends on how vital it is to them. So in some cases it might be the service companies see it as a way of offering a better service at lower cost, or it could even be the manufacturer who decides to offer this as a kind of free or subsidized value-added service to try and win and keep more customers. And of course, inevitably there's concern over security and privacy of if anyone can access your HVAC systems, that can be problematic, particularly if you've got a vital data center which could be affected. So, to conclude on the next slide some of the points, we think that this process is likely to come in phases, So you've already heard from Lorna's section that IP Connect capability is becoming more and more standard. Systems are pre-fitted, and we're also seeing software becoming important, which means you need to have a means of accessing and updating it. We think that having got this capability, systems will be connected to the web as and when it's really required and useful, and you may then have a basic connection, and then you can access more advanced monitoring and optimization as and when it's needed. So I'll now pass you back to Lorna, who is going to carry on talking about convergence and other issues.
Yes, thank you. We have over the years done a number of studies looking at convergence. So I will try and give you a little update of our latest study if you move to the next slide, because I think it's really important that we first define what we mean by convergence. So this chart here shows a common IP-based building network infrastructure that support a lot of coexisting applications and services in a building. Many devices, as we showed you later, are today IP, and the number continue to increase. Some buildings have one network, others have several networks depending on the ownership and the key drivers. In some buildings, it's the IT that take responsibility, or with other end users, there's a clear divide between the IT and the facilities. There's also big variations between the verticals, which we'll show you later. But as you can see, all the services are linked up to one or several networks and are then interfacing with each other. In the next slide, we have here some numbers, because we did a study last year focusing this time on the US, because there were so many numbers flying around in terms of IoT, and different types of scopes were applied by different research companies. So in this study we choose to base it on the actual network. So the chart here shows you the total amount of connected outlets or devices onto the network. So our base for this was the local area network, the copper cabling installed in the US, and typical 40 meters per drop are used. So the total number, as you can see here, are growing slightly, so we have that roughly by 2 to 3%. The number of data is decreasing in 2018 and dropping slightly. That is the blue area and the blue line. If you're looking at the wireless access points, it is the yellow area on the left side and also the red line in terms of the growth shown. We only looked at the wireless access point installed with new cabling, not the one that was added onto the existing network. But you can see that it is growing year on year. The IT is the green area and the green line, so the smallest base but the biggest growth in terms of from now and up to 2021. If you're looking at the next slide, we are showing what we included in the IoT. So there is a lot of products, and the biggest are the security area. It's surveillance cameras, access control, it's intruder alarms being installed either with or added to the BACS solution, installed at field level or maybe connected at management level. If you're looking at the other products, we are talking about AV, lighting, smoke detection, blinds, room picking, smart parking. Some products are likely to be added to the BACS from the beginning, such as heating, ventilation, air conditioning, and also increasingly, but still very small, lighting and access control. Other products are typically installed separately or on the IT networks, like the surveillance cameras and the access control also in this case. So there are a lot of different variations of the actual design and structure, and also if it's installed from new builds or added as a retrofit. If you move to the next slide, you can see the typical verticals for convergence. The most advanced one, and it's been the same over the last 10 years, we can see transport, many airports, most of these have some level of convergence. The HVAC, security, digital signage, crowd control, parking, lighting are often added up and converged. Retail, large shopping malls and chains of shops, some of the same features as before, but also point of sale, and also becoming more and more intelligent in terms of regulating the traffic in the store. It can be controlled directly, or it can be used using big data and artificial intelligence to get the crowds to move where you want them to move. Henry talked about hotels, where we see more and more individual controls via apps or via thermostat type devices in the room where you can regulate your heating and ventilation, but also adding information, booking systems, information about the area you are in. Education, that's where AV and whiteboards come in and often used for teaching. A lot of other verticals, healthcare, hospitals, mixed use, we see more and more, and mixed use are a combination of offices, residential and leisure, high-end offices, data centers and manufacturing. And also if you look at these verticals, they're often the same across worldwide, so you will see the same verticals being mentioned in the US, the UK, as you will see in India and Malaysia. Okay, I will move on to, I will leave it to Henry to finish the last bit.
Okay, thanks, Lorna. So, for the last section, I'm going to focus on the market for smart home devices and solutions. And if you look at the next slide, we will see one of the reasons why, certainly from a commercial point of view, this is very, very important to the whole smart buildings market. On the left-hand side, you can see BISRIA's estimate of the total smart buildings market for 2017, which totaled over $40 billion, including products and services. And what you can see clearly is that BACS, or building automation, is about as big as smart homes, smart HVAC and BEMS. So smart HVAC, you can see they're very much a market that's just starting to emerge. On the right-hand side, in contrast, what we're looking at here is the extra spend that we forecast is going to occur up till 2021. So this is additional spend from whatever source. And what's very striking there is that you can see that about 2/3 of this extra spend is going to come from the smart homes market, against only 14% for BACS, 15% for building energy market, and smart HVAC, you can see it's increasing its share, but it's still relatively small. So anyone certainly wanting to look at the overall impact and commercial importance probably wants to be looking at the smart homes market as well. Now, if we go on to the next slide, we can see here what kinds of products are people predominantly spending money on. Again, this is a global estimate. And you can see here that there are three categories of products that are particularly popular on a global level. In first place, we have lighting. No great surprise there. A lot of people have invested in better lighting in their homes. Temperature controls, also on 20%. Now, again, we've seen the strong movement towards people wanting to have smarter control to improve comfort and reduce energy consumption. And you can also see smart entertainment systems at 17%. Now, this is worth noting that smart entertainment here, we're not including everyone who has a so-called smart television in the world, because otherwise this sector would be much, much bigger. We're including those which are actually connected in some way to other systems within the building. It's also interesting to note that smart appliances at 5% is still quite small. I think this market has taken a bit longer to take off than some people have been expected. I think the main reason for this is a case of finding really useful and persuasive reasons to install smart appliances. I mean, how important is it really to have a dishwasher or those dishwasher tablets? It's probably not a life-changing event if we suddenly find we've got to go out and buy some. And the other thing is making these systems more connected to the overall smart system so that they can achieve full usefulness. And blinds are important in some countries, such as Germany, where people tend to have blinds installed in their homes. And these figures vary from country to country, but the broad themes are still the same. Now, another reason why, if we go on to the next slide, we'll see another big reason why anyone who's interested in smart buildings overall will probably want to look at the smart homes market. Because what we can see here is who is buying these systems. If we look at the pie chart on the right, perhaps as you'd expect, up until now, we're seeing that the biggest markets are for luxury villas and luxury apartments. And I think this is how smart homes have traditionally been seen. But you can see the next two segments, that the mid-range houses and apartments are also gaining importance. But perhaps what stands out as most striking is if we look at the sectors that we've pulled out of the pie, you'll see these include hotels, restaurants, offices, and other non-residential. And these between them amount globally to 37% of the spend. And in some countries like Germany, it's even higher than that. And these tend to be smaller non-residential buildings, which in many ways have a lot of the same requirements for energy management, for example, as you might have in a house. But this does have implications for the whole smart building market, as there is, of course, the potential for these solutions that start off as smart home solutions to move into other areas of the market as well. And if we look on the next slide, related to this, we have split the market into two broad categories. The blue line, where you can see almost linear growth, is what we call the whole home market. That's what you traditionally think of as smart homes. Typically a complete integrated system, probably costing quite a few thousand euros or dollars or whatever, and best installed when a house is built, and most likely to be found in luxury houses. In the red line, which you can see is growing pretty much exponentially, this is what we call the standalone or modular market. And this is the sort of thing that particularly that you or I could go out at the weekend and buy from a retailer. We're talking about things like the devices that companies like Amazon and Google and EcoBuild and Philips, where you can go out and plug it in and it works. Now, this market is growing very rapidly. I think the main challenge for this is that whereas it's designed to be very simple to set up a device, when you get to the stage where you're trying to create a complete smart home or smart building, you then face the challenge of how you fit all these together. And I think given different protocols and different standards, and I think this is a challenge for the whole industry going forward. The other interesting point I think about smart homes is that just the brands I've mentioned, we're talking about companies like Google and Amazon, and of course not forgetting Apple, and these are some of the biggest and most resourceful corporations in the world. They're really going into the smart homes market, and potentially they could have a wider impact on the smart building market if they choose to do so, and in affecting the whole way that it develops. So that's if we now go to our conclusions. So what have we seen in this presentation? We've seen that an increasing number of devices in buildings of all types are both intelligent and increasingly IP connected. Some of them are on a BACS network, some of them are on separate networks. We're seeing an increasing number of players coming into the building market, and I've mentioned some of the major household name corporations who are starting to have an impact on it. And we're also seeing new and innovative solutions such as smart connected HVAC with its associated remote monitoring that are starting to take off. So that really brings us to the end of the formal presentation. So at this point, if we could just go to the final thank you slide. So just thank you from both of us for listening to us for the past 39 minutes or so. And we'd now be very happy to take any of your questions.